Good day, class. Welcome to another section of our studies on functions. Today we are on range of a function, that is understanding output and image set. Let's move to the definition of range. The range is a set of all possible output values, into bracket the y values of a function. In other words, it is the set of values that f of x can take when x varies over the domain. Range is a subset of the codomain. So here, what we need to understand here is such that whenever you have a relation, we have the set of domain and a set of codomain. The range is the set that contains all the images, those that have objects from the domain. So if I am talking about the range, it means that I am talking about the output values, that is the y values of a function. Let's move to the next one. How do we find the range of a function? So here we have the steps to find the range of a function. That is what I said, every function have domain and range. The domain contains the set of objects and the range contains the set of images, that is the output. So if I want to find the range of a particular function, first step, I need to start with the function being y equal to f of x. It means that the function f of x will be given to me. So I need to let y to represent the f of x, where this y is standing in for the output and the x here is standing in for the input. Then the second version or the second step will be to make x the subject of the formula. That means solve for x in terms of y. That is what we need to understand. So here, let's cast our mind back to when we were dealing with domain. When we were dealing with domain, f of x was the subject. In other words, y was the subject. But if you want to find the range, then this thing have to change. Then x supposed to be the subject, not f of x or y. So to do that, it means that I need to make x the subject from the formula or the expression of the function which has been given to me. I hope we understand that. Because when we were finding the domain, f of x was the subject. In other words, y was the subject. So if you want to find the range, then it means that the range is for the output. Then x is supposed to be the subject, so that the expression will be in terms of y. The third step is to identify the values of the y, because the expression will now be on in terms of y. So you need to identify the values of y. That makes the x ray, and that will make that x function or the expression in terms of y to be defined. So always we need to check for restrictions such as square root or division by 0. Let's look at this particular example. We have example 1 here, which is f of x equal to 2x minus 3. From the steps that we just studied, we have to let y be f of x. So the moment y become f of x, it means that we can move to step 2, which y will be equal to 2x minus 3 because 2x minus 3 represent the f of x. So it implies that the next step is to make the x the subject, which in this form, to make x the subject, I'll maintain the 2x, which is positive here, then send the minus 3 across the equal sign, and the results will end up to be 2x equal to y plus 3. So when you divide both sides or each term by 2, we are going to end up with x equal to 1 over 2y plus 3 over 2, which this expression becomes a polynomial in terms of y. So if you look at this expression now, x is now the subject, which the expression here is in terms of y. Why? Because we are trying to find the range. So if I want to find the range, then we cast our mind back to when we were finding the domain of a function being a polynomial. So the range for this particular function will be in the form y being a member of R. Why? Because there is no restriction on y, because the expression here is a polynomial in terms of y. So the domain can be written as y is said that y belongs to all real numbers, or y is a member of R. So let's move to the example 2. For the example 2, we have the function f of x being a rational function of the form 5 plus 2x divided by 3 minus 4x. So here the same process. We let y equal to f of x, so it means that y will be equal to 5 plus 2x over 3 minus 4x. The next step is to make x the subject of this particular formula or relation. So here, making x the subject means that y is over 1 already. So we are going to use cross multiplication, where y will multiply this denominator and 5 plus 2x multiply the denominator 1, and it will be in this form. The next thing is to open the bracket. So when you open the bracket, it will be y times y, 3 give us 3y, then minus 4xy equal to 5 plus 2x. Since we are interested to make x the subject, then any term containing x, we group them at one side, then we group the rest of the expression at the other side. So when you look at this expression here, this term contains x, this term contains x. It's in your own interest to make sure that your grouping like terms will be in a positive format. So if you look at this one, plus 2x is already in the positive form, so I'll maintain it. Then this one, which is negative, will cross the equal sign, so that I'll send the 5, which is also here, to cross the equal sign to this side. So at the end of this manipulation, we are going to end up with this 2x being here, then the minus 4, which cause the equal sign to be plus 4xy equal to 3y minus 5. Now, since we are interested to make x the subject, then x is here, we need to apply the principles of factorization. We have to factorize the x outside the bracket, and when you factorize x outside, the expression that will be left inside the bracket will be 2 plus 4y equal to 3y minus 5. Now 2 plus 4y becomes an unwanted expression which is attached to x in terms of multiplication. So how do I get rid of the 2 plus 4y? I will get rid of it by dividing both sides by 2 plus 4y as you see here. Then x will be left alone. So here, if I want to write the range, then this one becomes a rational function in terms of y. So the range for this particular function means that I need to write the range where this particular function will not be going to an error. So if this function will be an error, it means that the denominator will be equal to 0. So 2 plus 4y will be equal to 0. when you solve for y, you are going to end up with y equal to negative 1 on 2, which means that the denominator can only goes to 0 if y becomes negative 1 on 2. So if I want to write my range, then the range will be in this form. Y is said that y belongs to all real numbers, and y cannot be equal to negative 1 over 2, because the moment y becomes negative 1 over 2, the whole expression becomes mass error and it becomes undefined. So check for this restriction. So the restriction is y supposed not to be equal to negative 1 over 2, which negative 1 over 2 will make the denominator goes to 0. So the range will be written in this particular format. Let's move to the next one, which is also a radical function. So we have example 3, and example 3 is in the form f of x equal to square root of 25 minus x squared. Good. So the same process will be taking place here. I will let y be f of x. So if y is f of x, then it means that y is the same as square root of 25 minus x squared, which implies squaring both sides to remove the square root. Since we want to make x the subject, the expression will now tends to be y squared equal to 25 minus x squared. Here we are going to make x the subject. So making x the subject here, it is negative. Since I want to make the subject in a positive form, I'll send the negative x squared across this equal sign, and it will be now be positive. Then the y square will also cross the equal sign, and it will be x squared equal to 25 minus y squared, which implies that to find x, it means that it's going to be square root of 25 minus y squared, which is going to be whether plus or minus. So to be defined, for this expression to be defined, for us to be able to get a range, then 25 minus y squared, which is under the root sign, supposed to be greater than or equal to 0. This principle is used as the same as when we were finding the domain for radical function of this form. So here we are going to get y squared being less than or equal to 25, and that will give us a parabola, and the only range that will give us a perfect answer is the range between negative 5 less than or equal to y less than or equal to 5. So since square root give only positive answers, y is supposed to be greater than or equal to 0. So if I want to write the range for this particular relation, then it means that my range will be y is said that y belongs to all real numbers, but the y that have an object in the domain will be between negative 5 and 5. So that is a short activity for you. So you can solve this activity and you send it to me personally to see at the comment section or through my email or the WhatsApp number. Find the range of the following functions: f of x in this form, g of x in this form, and h of x in this form. I'll be receiving your feedback. Thank you. God bless you. We'll meet another time.